What's going on, guys? My name is Johnny Bannon, and I will be your CCNA instructor for this CCNA video series. In this video, we are going to go over inter-VLAN routing, which is the final step to really completing our layer 2 section, or what I call layer 2.5, right? In this lecture, I'm going to go over how we get VLANs to actually talk to each other via IP, via layer 3. So kind of more layer 3 to layer 2 technologies, right? Bridging that gap. So I've noticed with this lecture that the concept is relatively easy to understand. What is inter-VLAN routing? It's essentially allowing our VLANs to talk to each other via layer 3, right? Because we segment them at layer 2 with that VLAN tag. So how do we accomplish this? And again, it's kind of easy to understand. We need a layer 3 device or a device that does layer 3 routing to be able to accomplish inter-VLAN communication. Now, there's a couple of different ways we can do this. We can do this with a router and implement a technology called router on a stick, which creates logical subinterfaces on the physical interface. Or we can use a multi-layer switch by utilizing switch virtual interfaces, which is a little layer 3 interface for that VLAN traffic. So to finish off this slide here, we can see that if we just have a switch out of the box, just layer 2, it ain't gonna happen, right? These VLANs won't be able to talk to each other because they're segmented via layer 2, which is the only thing this switch can forward, layer 2 frames. So inter-VLAN routing is just a term to describe the different ways we configure IP reachability between users, endpoints, and VLANs, right? Or networks. So to accomplish inter-VLAN routing, we either need a layer 3 device or layer 3 capabilities on a layer 2 device, a multi-layer switch, right? Again, the two ways we accomplish this is router on a stick, ROAS for the acronym. Essentially is a method of using what we call subinterfaces, which are logical on the router port connected to our downstream switch, and that's going to be how we route traffic between VLANs. So with that, we essentially create a sub-interface for each VLAN and assign it an IP address. And we also tell that sub-interface how that traffic is going to be tagged coming to that IP. So with the sub-interface, we're also going to tell it encapsulation .1q and then the VLAN ID that subnet is supposed to be for. And then with switch virtual interfaces, this is how we can convert that layer 2 switch into a layer 3 and can also perform routing via these SVIs or switch virtual interfaces. Let's take a look at a couple diagrams and examples. So here we can see R1 connected to this LAN down here. We have two VLANs, VLAN 20 and then VLAN 10 here. And then we see their different IP addresses or subnets. So what we're going to do here is we're going to trunk from this switch, we'll call it switch 1, up to R1. And then at R1, we're going to turn on this physical interface, right? That no-shut command. And then you see we're going to create those logical sub-interfaces. And then this actually has a sequential order to it. So once we create that sub-interface, before we can assign an IP address to that sub-interface, we have to tell it what VLAN tag is coming across and destined for this sub-interface. So we do that with this command encapsulation.1q10. An important thing to know is that this sub-interface number right here is not correlated to the VLAN tag at all. I could have made interface gig00.69 and I still could do encapsulation.1q10. Because this command right here is going to tell that sub-interface what VLAN traffic is going to come to it. Which tagged Ethernet frames should this sub-interface respond to with layer 3 capability. Okay? So meaning when we get a frame coming across here and it has an 802.1q tag inside the header with a VLAN tag of 10, that means sub-interface gig00.10 is going to be the sub-interface routing for that traffic, okay? Then same down here, this sub-interface is for VLAN 20. Now, it is best practice, however, to make these sub-interfaces correlate with the VLAN, and that's more for your administrative purposes, right? Because when we do a show IP interface brief, it's not going to show us the running config of that sub-interface. It's just going to show us an interface and then the IP address with it. When we do that show IP interface brief command. So it just makes it a lot easier when we're quickly navigating our router or doing troubleshooting to have these sub-interfaces match the VLAN number or tag or ID that they're routing traffic for. Okay, and then we have our other implementation here, which is using SVIs. So here we have a distribution switch, which already typically is, or a distribution switch should be a multi-layer switch doing layer 2 and layer 3. And what we have here is on this switch, we create our VLANs, our layer 2, right? We just create VLANs like we've always have. And then we create the corresponding SVI, where this does matter. Interface VLAN 10 will only respond to VLAN 10 traffic. And then we assign it an IP address. And it's really that simple and that easy, guys. That's how we use SVIs, okay? Why do I have this here? Shutting down interface VLAN 1. Because on some real-world switches, I know Catalyst, the 3000 series, which is legacy now, but you still might see it out there. It would come with VLAN 1 configured on it already, and we would have to shut it down if we don't want the native VLAN to have any IP reachability or to make sure that these come up. So we see that on some switches, so I just do that as best practice on all my switches now. Okay, and then this SVI. Before we end this lecture, I want to go over something else. So I'm going to go back to this slide here. Okay. So let's take a breather, right? We know that when we're doing router on a stick, we're using sub interfaces for layer 3 reachability for our VLANs. Okay. Now, what about these switches? They're layer 2, right? So would we be able to, let's say, sit on our beach house in Hawaii and SSH to these switches if they're just layer 2? No, we wouldn't, because there's no IP address on this switch. And how can this switch talk on the internet without an IP address? Really not possible, right? So what do? Even though these switches are only doing layer 2 for the endpoints and users, we can put a management interface on there, a management SVI. So what we could do is create a whole nother subnet, a whole nother network called VLAN 30. Give it a 192.168.30.0/24 subnet. And that will just be for what we call management, which means that will be the management subnet for all of our network devices so we can remotely manage them. So even though this router, yes, is going to be doing the routing for our VLAN traffic and our user traffic, we can put SVIs like SVI 30 on each switch to give it a unique IP address so that we can remote into these switches from our beach house in Hawaii. Now, during the Router on a Stick lab, I see it all the time. For some reason, all my students, especially my in-person or virtual courses that are live, when I see them start to configure their Router on a Stick lab, they start putting interface VLAN 10 and 20 on every single switch. So it's important to know that if this router is acting as the default gateway for your VLANs, you don't need SVIs for every VLAN on your switches. The router's taking care of that. The only SVI we should see configured on like our access switches, which these would be our access switches, is just the management VLANs, subnet and SVI. And I'm going to hit that again in the lab just so we can reiterate that, okay? So with that being said, I believe this completes our inter-VLAN routing lecture. Stay tuned for our next few videos. We're going to be going over Router on a Stick Lab and our SVI lab.